This video is on classwork, chapter 8, classwork number 5, page 31 to 32. If you are absent today from class, I would recommend doing it on the Canvas or Cami paper, because we're going to be adding the graphs on using Desmos, and then that way you don't have to draw them out. So on this, I'm going to ask you to pause so you can try to figure some of this out and then restart the video. So on this, what we're going to be doing is 8-32, saving for college. So we have two situations. Suppose you have $1,000 to invest and know of two investment options that offer a % annual interest rate. You can invest in bonds, which pay 8% simple interest, or put your money into a credit union account, which pays 8% compound interest. Will the option you choose make a difference in the amount of money you earn? Examine these two situations. So the first one here that I'm going to highlight in this teal color, that is our simple interest. This one over here that I'm going to do in pink, this is our compound interest. So both situations, what you'll notice is we are starting with $1,000 year 0. And both of them have the same amount year 1. But after that, they are different. So right now, what I want you to do is figure out what are we doing in the first table to generate these numbers. You can just write it on the side what you're doing. Then what you're going to do is answer what it would be for the fourth year. Then you're going to do the same over here for the compound interest. So you can pause the video, try that, and then come back and we'll talk about the answer. Okay, so hopefully you tried the problem so that you can kind of see what's going on. Now, kind of what I notice here is the difference between these two is 80. And here to here, I'm also adding 80. So each of these, we are adding 80. So to get the next one, I'm also going to add 80. So if I add 80 onto 1,240, I am going to get, so what am I doing? 1240, and I'm adding on 80. I am going to get 1,320. Okay. So in this situation, what are we doing? So it says, if you invest in bonds, your $1,000 would grow as shown in the table above. How does this amount of money grow with simple interest? So what we're doing is we are adding $80 each year. Adding $80 each year. That's what's happening. So then for the next one, we need to figure out what we're doing in the next one. Now, I'm not adding 80 each time. Between the year 0 and 1, it was 80, but that's not what's happening. So I'm going to jot down a little note. This one here is arithmetic because we're adding the same thing over and over again. So I'm wondering if this one here might be geometric for the other one. So what I'm going to do is I'm going to be looking at what's happening between these. So one way to do this is say, okay, if I'm starting with 1,000, what can I multiply it by? I'm just going to call it X to get 1,080. So if I was to solve this and divide both sides by 1,000, I get 1.08 as my answer. So let me see. Is that what's happening every time? I'm multiplying by 1.08. So let me just get a Desmos here so we can see. Okay, so if I take 1,000 times 1.0808, I did plus, sorry. 1,000 times 1.08. You see, I did get that. Now, what happens if I times it by another 1.08? Okay, I got my 1166.4. And again, times it by 1.08. Okay. And then one more time, I'm going to times it by 1.08. And so that's what I'm going to get here, 1,300. Let me just get that to pop back up, sorry. 1,360.49. Okay, 1,360.49. So for this one, what we're doing is we are multiplying by 1.08. That's what we're doing. And again, this is going to be geometric. Now, what we did in class today is we tried to come up with the equation for both situations. So see if you can come up with an equation for the bonds with simple interest table and a separate one for the accounts with compound interest. So if you want to pause it and come back and try it. So hopefully you're able to come up with the equation. So for the one with simple interest, I'm looking at what I'm starting with. I'm starting with 1,000. So I'm going to go y is equal to 1,000. And then what am I doing over and over again? I'm adding 80 x times. That is going to be our equation. Okay. And that equation, when we graph it, this is going to be a line. It's going to be linear. So now let's come over to this one. And for this one, I am again going to have y equal. This time I'm starting again with 1,000, but I'm not adding, I'm multiplying. And I'm multiplying by 1.08. And when I multiply over and over and over again, I raise that to the power. And that's my equation for the compound interest. Okay, so, and that's going to be a exponential graph. So then on part B, they're asking us what percent would your balance have increased by at the end of the 4th year? They're asking us for both tables. So what I'm going to do is I'm going to look at how much we have year 4, which is 1,320. I'm going to subtract what we started with. And so by year 4, we earned $320. So when I want to find what percent would your balance have increased by, we take 320, which is how much we made, and compare it to the 1,000 we started with. When I put this into my calculator and I take 320 divided by 1,000, I end up getting 0.32, which means 32%. Okay, we've earned 32%. Now, I'm going to do the same for the other one. So I had 1,360.49 by year 4. We started with 1,000. When I subtract, I get 360.49. So again, I want to see what percent is that of what I started with, of the 1,000. When I put that into my calculator, I end up getting 0.36049. So that's going to be about 36.0, let's say 5%. So you see that we are getting more interest, even though both of them are 8%, with the compound interest. Now, the difference between simple interest and compound interest is simple interest, when you get 8% simple interest, you get 8% of the original amount you put in. So this 80 that we kept adding and adding and adding and adding, how that 80 came about was if you take $1,000, which is what we started out with in the bank originally, and times it by 8%. 8% of $1,000 is $80, and that's what you get year after year after year after year. No matter how much money you have in the bank, it is 8% of what you put in originally. Okay, so you never get more, it's always the same amount. For compound interest, what's happening is we're getting 8% of what is in there that year. So when we have 1,000, 8% of 1,000 is 80. So we got 80. But then the next year we're taking 8% of not 1,000, but 1,080. And then the next year we're taking 8% of $1,166.40. So every year we're making interest on our interest. That's what compound interest is. It's 8% not of the original amount, but 8% of what was in it, what is in there currently. Okay. And how we got this 1.08, we got this 1.08 by taking 100% of the amount, like the 1,000, for example, for year 0, and adding on 8%, okay, which is the 80, that's how we got the 1,080. And that is 108%. So every year we're working on finding 108%. So that makes a multiplier of 1.08 when we move our decimal 2 places. Okay, then the next thing that we did is we took these two equations and we put them into Desmos. And then we're going to put that on the next page. So let me just get my Desmos over here. Okay, and so you can do this too. Open Desmos. Okay. And I'm just going to stretch it out a little bit. And what we're going to do is I'm going to put in this 1,000 plus 80x. So y equal 1,000 plus 80x. Forgot the 1,000 plus 80x. I'm going to open this up. Right now, I'm not seeing anything here. The reason we're not seeing anything here is because this is starting at 1,000. So if I zoom, 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 we start seeing something. But the problem is when we're scaling this, this is scaling both the X and the Y axis the same. So my X is scaling by, for example, here, 2,000s, and so is my Y, but that's not very helpful to me. I don't need 2,000 years if I'm trying to find my money, okay, that started at 1,000, I need my X to be different scale than my Y. So I'm going to come here to the wrench, okay, to the wrench right here, okay, wrench. I'm just going to make this a little bolder. That's all that does. Okay, so I'm going to come here to the X axis, and I am going to make this be from 0 to, let's say, 20, okay? And then my y-axis, the very start is 1,000. So I'm going to start at 1,000. And then let's say we go up to 3,000. Okay, so again, I went from 0 to 20 on my x, 1,000 to 3,000 on my y. And now we can kind of see the graph a little better. Now, I'm also going to come here and put the other equation in, which is y is equal to 1,000 times the quantity 1.08, and then to get it to be raised to a power, I'm going to do shift and 6, and that raises it to the power x. So here you can see the exponential. So you can see this compound interest one is definitely giving me more money in the long run than this linear one. Now, the one thing I want us to notice, and I'm going to clear this. I'm not going to clear it. I'm going to press this where it's the color here, and it disappears. and I want to just see this linear one for a second. And so for this, I don't get all this money throughout the year. I get $80 at the end of the year, 80 more at the end of the next year, 80 more at the end of the next year. So I need to make this graph what we call a step function. So what I'm going to do is I'm going to move my cursor right in between the 80 and the X. I really want it in front of the X. And I'm going to write the word floor, F-L-O-O-R. Okay. And I'm going to put parentheses around the X. Now, what this floor does is it makes the step. Okay. We have something called a floor and something called a ceiling. So when I'm here at 0, I have that 1,000 no matter from 0 until the next year when it's 1. Then when it's 1 point, I don't care if it's 1 point, whatever, not until it gets to 2 will it move up to the next one. Okay. And that's a floor where 2.7 gets pushed down to the value at 2. Okay. That's all the floor means. But this is considered a step function. So I'm going to take this and I'm going to put this onto my graph. So I'm going to come up here to the share. I'm going to click down here on export image. I'm going to actually do it as this medium one. Okay. And I am going to download it. So now I have it. And I am going to move this for a second. I'm going to come over here to this screen. And I am going to upload this image here. Oops. Upload this image here. And so that is my graph. And again, I'm going to write the equation for this one. This one was y equal 1,000 plus 80x. And this is a linear situation. This is an arithmetic sequence. And this type of graph that I just did is called a step function. Okay, so now I'm going to come and get this again. I am going to unclick that one and click this one. And I want to do the same thing here because, again, I get it at the end of each year. So in front of the X, so I'm going to click up in the exponent. And in front of the X, I'm going to write the word floor, parenthesis. And here is my step function. Okay. And again, for year 0, until I get to 1, it's going to stay the same value as it was at year 0. Then at year 1, it's going to stay at that for the whole year until I get to 2. Okay, that's a step function. So I'm going to come up and share again, export. Again, I'm just going to choose the medium. I guess it's thick or medium. Doesn't matter, whichever one you prefer. And I'm going to get that here. I'm going to put it onto my graph right here. And there's my graph. This one here is going to be y equal 1,000 times 1.08 to the power x. This is an exponential graph. And this is a geometric sequence. Okay, on 8-34, it says in previous chapters, you've used models to estimate actual behavior. Creating a linear model for scattered data gave you a mathematical way to describe the data and make predictions. The amount of money in an investment account earning simple interest or compound interest, such as the situations in the problem 8-33, can be modeled with step functions. That's what I made those into. So writing equations for step functions can be very complicated. However, we can model the step functions with continuous functions we are already familiar with. So that's what we were doing here. Okay, so when I get rid of this word here, floor, okay, on Desmos, it changes it back to a continuous linear graph and a continuous exponential graph. But again, when I put that word floor in there, it makes it into the step function that is the situation for these problems. Okay. Now that's as far as we got through today. So after we got these graphs on here, we ended up submitting this. So make sure you submit this and get your points for classwork today.